Hello, and welcome to another Windows Phone How Do I video. In the next few minutes, I'm going to show you how you can build a Windows Phone game using the farseer-physics engine. Before we start coding, let's talk about how the farseer-physics engine works. The first thing to understand is that when you build a physics-based game, you are really creating two distinct worlds. I'll refer to these as the physics world and the graphics world. The farseer-physics engine will be responsible for maintaining all the information about the objects that you create in the physics world. You simply add objects and define their physical characteristics, and Farseer will update their position based on how they interact with each other and with gravity. So Farseer does all the heavy lifting, but you are still responsible for putting pixels on the screen. So, you'll use the information that Farseer has calculated about each object in the physics world to put graphics on the screen using standard XNA. Let's talk Farseer fundamentals. To begin with, you need a world. Farseer uses a world object as a container for everything that will exist in the same physical space. Next, you create a body. It represents a point in space that may be affected by forces such as gravity or collisions with other bodies. Of course, you want your game objects to be more than just a single point, so next you'll define a shape. This represents the object's physical characteristics. In Farseer, a shape can be simple, like a circle or rectangle, or it can be much more complex. Finally, you'll need to attach the shape to the body, which is done with a fixture. That way, when you move the body, the shape moves along with it. Let's get to work. If you haven't already done so, you'll need to make sure you have Visual Studio 2010 installed and the latest Windows Phone tools. I'll be using Visual Studio 2010 Professional, but you can use the freely available Visual Studio 2010 Express for Windows Phone. Now, the Farseer Physics engine is available at farseer-physics.codeplex.com. You'll want to download the latest version, which in my case is 3.3.1. Go ahead and grab the recommended download, which includes some very useful samples. Now, I've already downloaded and extracted the zip file, and I've placed it on my desktop. As you can see, there are samples available for PC, Xbox, and Windows Phone. You'll need to open the Windows Phone solution and build it. Otherwise, you won't have a compiled DLL that contains the actual physics engine. Now, I've already done this. So, let's switch over to Visual Studio. Now, I'll create a new project, and of course this will be a Windows Phone game. And the template I want is Windows Phone game under the XNA Game Studio 4.0 category. I'm going to call it Smiley Place. Note that I'm going to target the latest Windows Phone version 7.1. We'll need to add a couple of references in order to get the functionality we want. Since we'll be using the accelerometer, I need to add a reference to Microsoft.devices.sensors, which can be found under the .NET tab, and of course, I'll need a reference to the Farseer DLL, which we discussed earlier. We're going to need some graphics. Now, I've already created some, but really they're just some circular faces. They are ping graphics, PNG files, so we'll add those to the content project. Next up, a little bit of housekeeping. Our game is going to be played in portrait mode, whereas the default orientation, at least for an XNA game on Windows Phone, is landscape. A few lines of code in the game class constructor should handle the orientation for us. Note that I'm going to switch the orientation to portrait, and I'll set the preferred back buffer width and height accordingly. To simplify the drawing of textures in XNA, I'm going to add a sprite class that handles some of the more mundane aspects of the graphics. The relevant part is that it calculates the center of the graphic as the origin. That's useful when we're dealing with physics. Now, back in the game class, let's add some member variables. And to keep things clear, I'll add some regions. We're going to begin with the graphics variables that will help us put pixels on the screen. And all of this is typical XNA stuff. Note that I'm creating several sprites that represent the player and some other objects that will be part of our game. Now let's add some physics variables. This is the farseer stuff. We need one world, and we'll add the using statement for the farseer namespace, of course. Plus we need a body for each game element. For now, we'll just add a body that represents the screen boundaries and a body for the player. Finally, we need some variables for handling the input mechanism, and this is just some standard accelerometer code. So now it's time to get to the actual code itself. We're going to do most of our work in the load content method. Let's go ahead and find that. First up, a line of code to grab the current viewport. That's going to be useful later when we need to calculate the midpoint of the screen. As before, I'm going to handle the graphics world first by creating a sprite with a texture loaded through the standard content pipeline. This sprite will be used to draw the graphic that represents the player. Now I'll deal with the physics world, beginning with the world object. Now this farseer world uses a coordinate system to track its objects, but unfortunately this coordinate system is not the same as the pixel-based coordinate system in the graphics world. Fortunately, the farseer samples include a very handy class called convertutils, which can be used to convert sim, or physics units, from the farseer world to display units in the graphics world, and vice versa. So I'm going to add this class to my project, and trust me, this will save you lots of time and lots of math. With that class available, now we can set up the player body. Farseer provides a factory class that you can use to create bodies attached to a provided world. Next, we need a shape. I've kept things simple with a circular sprite, so a simple circle shape will work just fine. I need to specify the radius, which I can calculate from the texture we loaded earlier. Note that I'm using the conversion utility to translate display pixels to simulation pixels. Now at this point, the circle shape object is not connected to the body. That's where a fixture comes in. So with the create fixture method, we tie the body and shape together. Now let's set some properties on the body. We'll set the body type to dynamic, and then we'll set it in the center of the screen. This is where the viewport we created earlier comes in handy. Finally, I'll set the body's restitution. This number is related to the object's elasticity. Next, we need to define the boundaries of the physics world. Otherwise, our objects will just float off into space indefinitely. Now, to save a bit of typing, I'll use a snippet to insert a method called getBounds. This method just returns a set of vertices that represent the left, top, right, and bottom bounds of the device display. So I'll create another body that represents this boundary. Note that we can use body factory again, and this time we don't need a shape or fixture. It's all handled for us thanks to the bounds that we created earlier. We will make sure that everything else in the world will collide with this body. So we set the collision categories, and we set the collides with properties. This will keep everything contained on the device display. Now one more thing in the load content method. We need to start the device accelerometer so that we have a way to control the player on screen. This doesn't have anything to do with farseer-physics, so I'll just use a snippet that initializes and starts the accelerometer. Now, in a typical XNA game, the update method is where you process game logic. In our case, we need to do two things. First, we need to deal with the accelerometer input, which we do by applying it as a force to the player body. Second, we need to tell the physics world to step forward in time. This will cause the Farseer game engine to move all the world's objects based on their current inertia, rotation, etc. Now let's move to the draw method. This is where we paint pixels on the screen. In this case, we'll use the draw method in our custom sprite class to do the actual drawing. Now, you'll note that although the graphics comes from the sprite itself, the position that we want to draw the texture at is to be coming from the physics world, which means we use the convert utilities functionality to convert the player's position in the physics world to the display position in the graphics world. Now we're ready to go ahead and see what we've built. So let's debug the game and switch to the emulator. Now I'm going to use the accelerometer support in the emulator tools to simulate motion. If you haven't seen this before, all you have to do is click the arrows on the toolbar of the emulator. Then make sure you're on the accelerometer tab. In this case, we want it to be portrait flat as orientation. And then now notice how I can grab the red dot in the center of the accelerometer tool and simulate the motion of the phone. Note that in the game, my player responds to that motion. And when I set it back to flat, the player stops. So at this point, we have a working program, but we really don't have a game yet. So let's use what we've learned so far to turn this into something that's actually playable. First, we need some other game elements. To store these in our game, I'll create a list of type body. And then inside load content, we first need some textures that will be used to paint these other elements. I'm going to use two textures that are going to represent the other shapes. Something I'll call blue texture, which will load through the content pipeline and then create a sprite. And then, with the magic of copy and paste, a second texture called green texture. And this will be a second sprite. Now we're going to create a number of other bodies using the same techniques that we saw earlier. This is the farseer-physics part. So we're going to initialize the list of other bodies. We're going to do some randomization that's going to help us with placement on the display. And then I'll create a loop. Let's go ahead and do 16 other game elements. And then inside the loop, I just need to create all of the farseer-physics components. So we'll use body factory to create a body just as we did before. These are also going to be circles, so we'll create another circle shape. And again, we'll base it on the texture size to make sure that the physics world and graphics world match up. Remember that the body and shape is connected thanks to a fixture. So this is, again, the same code that we did before. We also want these bodies to be dynamic. And in this case, instead of putting them in the center of the screen, we want them all over the screen, and we'll just place them at random locations. Next, I'll set the restitution. Again, this has to do with the elasticity. And then I'm going to do a couple things that I didn't do with the player body. One is to set the user data of each property to false. That's going to make sense later. And I'm also going to add them to that list so we can keep track of them in code. Now, for purposes of our game, we need to know when the player collides with any other game element. And with Farseer, this is really easy to do. All we have to do is register an event handler for the body's on-collision event. Now the handler will simply retrieve the body that the player collided with. This is referred to as fixture B in the incoming parameter list. And then we check to see that it's an other body. The other option would be a boundary, and we don't need to react in any special way to the boundary. But note that we're just going to toggle the user data. So if the user data on the other body is false, we make it true. If it's true, we make it false. We don't actually need to update the update method, but we do need to draw the new bodies. So I'm going to do a list where we iterate through all the other bodies, and then we use our sprite draw method to display each one. Again, it's the same code as before, except this time we're choosing which sprite to display based on the value of the user data. So if the user data property is true, we display the happy sprite, otherwise we display the sad sprite. Once again, convert utils in order to be able to calculate the position, and this time we're actually going to use the rotation. The player body will never rotate, but the other bodies will, and Farseer will just handle that rotation for us. We don't need to do anything extra. Let's go ahead and debug the game and see what we've ended up with. Notice that we've got lots of game elements, and as before we can use the accelerometer tool to test. Note that we're getting collisions where the sprite changes. We get these collision detection, the objects bounce off each other, we get rotation on the other bodies, and all of that is being handled by the Farseer physics engine. And there you go, a simple game using Farseer physics.